Hi, so in this video I want to go over 5 tips for reducing noise in sensitive electronics applications. I want to begin with a key component, the LDO. The LDO is a low dropout regulator or a linear regulator. It's usually fairly simple compared to a SMPS switch mode or component. It doesn't have the same switching frequency noise, and there are many different topologies. A common one that you'll maybe learn in engineering school is this op-amp and transistor-based topology. So you can be very close to V in and V out. So you can have 5.2 volts and you can get 5 volts out. Now, an LDO is going to give you a powerful way to step down voltages, but it might not be helpful when you're stepping up. But there is a way around that. So you first start with your boost converter, then you go with your LDO, and then you have your filtering component here, and this is going to be your output signal. So an example could be 3.3 to 5, step down to, or you can boost it up to 5.2, step it down to 5, and then filter it. So you have a nice 5 volts here. Another common application is 3.3, boosting it up to 3.9 or something like that, and then stepping it down to 3.3 again. So you might think to yourself, why would you do that? And this is because you don't know what the noise level is on the voltage coming in. So if you're designing a PCB and maybe another department is designing a main board and you're designing your board, you're getting your 3.3 from the power board or the main board, and you don't know how clean it is. You can then run it through the LDO, but since you only have 3.3 and the LDO is going to step it down, you have to boost it up a little bit and then you bring it down again. There are common things you might have to think about when you're using an LDO. That is, can it supply enough power, and am I burning a lot of power with my LDO? So those are 2 things you need to look out for. Will your LDO burn hot, and is it giving me enough current, enough power? Second, putting a big or bulkier input capacitor will create a low pass filter and remove some of the high frequency noise. So as a schematic designer, you have the option of placing a higher value, bulkier, typically 1 micro to 10 microfarad capacitor close to the input pin of the LDO. Tip number 3 is to do the same thing but on the output pin. Put a big bulky capacitor on your output. This will help stabilize the voltage, help you source the current, and it'll also remove high frequency noise. And tip number 4 is to use an additional filtering sequence here. So what kind of filtering sequence would that be? Well, you need to be careful how you filter it. One topology could be the pi filter, could be something like this. You're basically sandwiching a ferrite bead or inductor like that. So this is going to be your input, this is going to be output. Tip number 5 is a more bulky decoupling on your power pin. So where you're getting power from could require a big bulkier capacitor. And finally, when it comes to the PCB design, avoiding ground loops. So a ground loop might be, you might have 2 grounds like this in your circuit design, and this point here might have higher potential than this ground point here. We don't know that. This is real life, not a model or theory. So it could happen that the potential will be higher at this ground point. So there will be a current flowing in this loop. It might not be a lot of volts, microvolts, millivolts, but it could be enough in a low voltage situation, and it could be amplified and make the noise worse. So make sure you avoid these kind of ground loops in your design. It might look something like that, maybe. And here you'll have another ground loop. So those are my 5 tips for low noise application design. Hopefully this helps you in your project.